Um, okay. Uh, Thanks everyone for staying late until the last talk of today. My name is Loi Luu. I'm a co-founder of SmartPool project, and I'm also a PhD candidate at National University of Singapore. So today I'm going to talk about SmartPool, the project that decentralizes the mining activities in existing cryptocurrency using smart contract. So here's the outline of my talk today. I'm going to talk about what is mining and what is pool mining, and I will explain why centralized mining pool are creating a lot of problems. I will then present our solution, which is smart pool. So first of all, what is smart pool? What is mining? So existing cryptocurrency like Bitcoin and Ethereum, they use a Nakamoto consensus protocol to secure the network. So specifically, Nakamoto consensus probabilistically elects a new leader to propose a block in every epoch. Basically, the miners, they have to solve the proof of work, which is also called the mining process. So mining is also a way to issue new coins in existing cryptocurrency. So the new coins are to compensate for the leaders when they successfully have their block included in the blockchain. So right now in Bitcoin is 12.5 Bitcoin per block, and in Ethereum is 5 Ether per block. So how do you mine a block? Technically, the miners, they need to find a nonce so that the output of this hash function is less than some predefined number d. And the smaller the value d, the harder it is to find a valid nonce. So this is the proof of work function in Bitcoin. In Ethereum, it's a little bit different to make it ASIC resistant. So here, Ethereum requires the miner to have access to a data set of 1 gigabyte, so that it's very hard to create an ASIC device to mine in Ethereum. So basically, finding a valid nonce is very hard. It's extremely hard now. The normal computers may take years to find a valid nonce, which will create a valid block. So that's why mining pool exists. So the high-level idea of mining pool is that a group of miners join hands so they mine the block together. So if one of the pool miners they find a block, the reward will be split between all the miners in the pool. Doing this will reduce the variance of the reward for the miners, but at the same time, the miners they will receive smaller rewards at higher frequency. So how mining pools work? So basically, the pools they track the miners' contribution by using something called share, and a share is similar to a block, but it's requiring less work to find. So for example, this is the condition of finding a valid block, and this is the condition of finding a valid share. So the only difference here is the D number. Remember that the smaller the value d, the harder it is to find a valid block. So finding a share here is much easier than finding a valid block. So we can see that each share they will have some probability of being a valid block, and basically the pool operator will record all the share that the miner submit to the pool, and if any share is a valid block, the pool will distribute the reward to all the miners. So this figure summarizes the whole mining process in existing cryptocurrency. So we have the solo miners, we just directly solve the block, and they compete with each other. And we also have the pool miners, they just join some pool and find the share. So pool mining is great for the miners because it allows the miner to have stable income, and it reduces the variance of the reward. So that means it's easier for the miner to make economic plan. It's also great for the network because it increases the security of the network by allowing more miners to join the mining. However, centralized pool are creating several issues. So first of all, mining in cryptocurrencies is highly centralized. So we can see that in Bitcoin and Ethereum, only 3 to 5 pools will control the majority of the hash power. So as a result, all the decentralized cryptocurrency network are secured by a few centralized operators. We have another problem, which is so there is some implicit trust between the miners and the pool, because the miners have to trust the pool to record all the share and pay to the miners correctly. There is also the transaction censorship threat, which is very serious here, because only the pools can decide which transaction to be included in the block, not the miners. So if the pools they don't like some address, some transaction, they can always exclude all the transaction from the blockchain. There is also single point of failures, which has been demonstrated in the recent work by some researcher from Tel Aviv University. So basically, because of the centralized mining, now it's easier to partition the whole cryptocurrency network. So here I present I will next introduce our protocol, namely SmartPool, which addresses all the centralized mining issues. So basically, we replace the pool operator by smart contract, and although the idea might seem to be very simple to you, there are a lot of problems to address in order to make it work. So in order to show that, I will present a naive solution for you first. So here we have a smart contract which acts as a mining pool, and we have there's some pool gateway which allows the miner to connect to the pool. So the miners just talk to the gateway and get the work template from the pool. So basically, the miners just use the pool's address as a Coinbase address in their block, so that later on, if the miner find a valid block, the reward will come to the pool. So if the miner they find a valid share, they will submit the share to the contract. And if a share is a valid block, then the reward will be split between all the miners in the pool. So this naive solution have a lot of problems. The first one is the number of shares in order to find a block may be very large. It may require billions of shares per block, and as a result, it may require as many messages to send to the contract. So with the current capacity of the network, like Bitcoin and Ethereum, we cannot process this many messages. And secondly, the cost to verify an ETH proof of work is very expensive. It may be more than the reward per share, and this cost the miner have to pay for it. So it may render the negative income to the miner. So a little bit more about the ETH proof of work. It was thought to not even technically feasible, because in order to verify the ETH proof of work, you need to access to the 1 gigabyte data set. And the smart contract storage is very costly. In order to store this 1 gigabyte, you may have to pay something like $80,000 US. So I will next present how we address all the challenges in SmartPool. So the first part of our solution is to allow miners to submit their share in batch. So each batch of submission may include millions of shares. So this will significantly reduce the number of transactions to the contract. And here we only ask the miner to submit the Merkle root of all the share. So the message size is very small. Right. So the second part of our solution is to use probabilistic verification to check every submission. So basically, for every submission that has a lot of share, we just sample randomly only one share to check. And if the share is valid, we accept all the share in the claim as valid. So this approach may look very insecure to you, because the miners can cheat. They can fake a lot of share in their submission, right? But our observation is that the more the more you cheat, the higher the probability that the cheating is detected. So this simple observation allows us to use a simple penalty scheme to disincentivize all the cheating. So our penalty scheme is that we pay 0 if a submission is for a submission if the cheating is detected, and so with this we can show that the expected reward is the same whether the miner is cheating or not. So with this, the miner have no incentive to cheat at all. So in order to explain this, very counterintuitive result, I will use some simple example here. Suppose that I find 4 valid share, and the reward for submitting all the 4 share is 1. And now I decided to, faking 2 share, and I submit, all the 6 share to the SmartPool, and I will have to go through the probabilistic verification process. And I can get 1.5 reward if I successfully cheat the pool, and this happened with 2/3 probability. And on the other hand, I will get 0 reward with 1/3 probability, right? Because I have 2 invalid share, and when I randomly sample 1 share, the probability of 1 valid share is sample is 1/3. So with this, I can calculate the expected reward is 1, which is the same as a reward if I just honestly submit all my share. So we can show that if we sample more than 1 share, we can strongly disincentivize the cheating miners. So this is to show the power of crypto economic. If we use crypto economic properly, we can improve the performance so much. So one question that I haven't addressed is that how do we verify the ETH's proof of work inside a smart contract? So verifying ETH's proof of work was thought to be impossible because of several reasons. So here we have the hash function of ETHs, and the data set here includes 64 random elements from a 1 GB data set, and we can just store the entire 1 GB data set because the cost is so huge. And you can say that can we just store the 16 megabyte data set, because from the 16 megabyte on we can generate the 1 gigabyte data set. This is just how the ETH's proof of work is implemented. But this approach is not feasible because storing the 16 megabyte is also very expensive. And this 16 megabyte data set changes every 30K blocks, which is around 4 to 5 days. Also, getting the element in the 1 gigabyte data set from the 16 megabyte one is also very expensive. It's going to require 8 sharp 512 computation per element. So your contract may run out of gas. So our observation here is that we do not need to store the entire 1 gigabyte, nor the 16 megabyte one. We only care about the correctness of the 60 randomly sampled elements. So what we do is we store the Merkle root of the 1 gigabyte data set in the contract, and everyone can verify this Merkle root because everyone has access to this 1 gigabyte data. And to verify one ETH's proof of work, we ask the miners to send the Merkle proof for each of the data elements. And checking the proofs for the 64 data elements is much cheaper and simpler. So we have implemented our ETH's verification in the testnet, and we self-implement the SHA-512 computation in Solidity. It costs around 200K of gas per computation, and we fully verify an ETH's proof of work with around 3.9 million of gas, and is it doable with the current gas limit in the mainnet? We want to emphasize that this can be optimized further because right now everything is just prototype. Um, and our solution can be used to build a lighter light client, because right now most of the light client they require you to store the 16 megabyte data set. Here we don't need to store that. So you can find more details about SmartPool protocol in the papers. Several questions that I haven't addressed, like how do you prevent the miners from stealing other share, and how do you prevent claiming a share multiple times? How do you run mining pools for other cryptocurrency like Bitcoin or Zcash on Ethereum? So you can find all the details of this question in our white paper. So this slide summarizes all the features that SmartPool offers. So we guarantee that the mining is totally decentralized. The pool is secure and is efficient. Our testnet deployment show that the miners have to pay less than 0.5% of the reward, which is even less than the fee that the centralized pool are charging the miners. So SmartPool is an open source and non-profit project. So our plan is that we are going to deploy SmartPool on testnet in March, and the mainnet deployment may come in May. Whether we can support other cryptocurrency or not, it depends on funding. And speaking of the funding, we are calling for donation. So right now you can go to smartpool.io, and there will be some instruction on how to donate to our project. And right now, when you donate to SmartPool, there will be some SmartPool token that is issued for you. So the SmartPool token do not have any value right now, but in the future we may consider some way to compensate the token holders. So to conclude my presentation, I want to share some thought from my experience working on SmartPool. So first, I want to say that blockchain and smart contract have removed middleman and centralized operator. So here we show one example, which is decentralized mining pool, which we use smart contract to replace the pool operator totally. And blockchain and smart contract are only the tools, not the solution. So a lot of effort and thoughts required on the design and implementation. For example, it took us around 2 months to go from the naive solution to the full solution. Before finish my talk, I want to thank Ethereum Foundation, Dina Durham, and 24 other pseudonymous donors for supporting SmartPool. I wish that we will have a chance to thank more donors in the future. So with that, I want to conclude my presentation. Seems like I have more time. I have time to answer some questions.
Yeah, I was wondering, without including it, but would it be a lot simpler to make SmartPool work Bitcoin mining pool instead of Ethereum? On Ethereum, not for Bitcoin.
Right. So first of all, verifying Bitcoin proof of work is much easier. It's simpler, but you need to guarantee, you need to guarantee the correct payout to the miners, right? While you run the pool in Ethereum network. So it's a little bit trickier, right? But it's doable.
How do you plan to protect against attacks on the pool? If a bigger pool tries to not publish their shares?
What kind of attack again? Sorry.
There was an attack on the Bitcoin pool like several years ago when some bigger pool published shares but didn't publish real blocks, and that's supposed
Right. So a short answer is that we cannot do anything about that. So all the pools are vulnerable to block withholding attack. There's no way to prevent that attack.
Which computer is calculating the local tree?
So you have to use your local computer to calculate that. I mean, we can run our own server and calculate that and push it to the blockchain, to the contract. But you can always verify that Merkle tree locally, because you have the access to that 1 GB data set.
Yeah, so if you submit a wrong route to the blockchain, presumably others prove to the contract that it was the wrong path?
Well, the contract will just verify it. No one has to send another proof to show anything.
But I mean, since it's a wrong route path to the data set, you have to prove that that was wrong.
So I have to prove that it's wrong.
Well, no, sorry, I was saying you said that you have the root hash of the data set of the blockchain and everyone can verify that it's correct.
Right. Yes.
What is the time correct?
We haven't thought about that actually. So I guess someone can complain, and miners just create a new pool and join that pool. Right. Because it's totally open, right? Yes.
Have you considered putting a penalty on cheating? It seems like there's a cost just to verify and for the potential payout for everyone else. So, not paying anybody to the extent they cheat, it seems like there is still some effort lost.
Can you speak louder?
Have you considered putting a penalty on cheating? You said there's like, zero payout if somebody's detected cheating, but it seems like there is some potential cost, so maybe it could be penalized with deposits.
Right. So if we sample more than one share, then we can penalize the cheater. Like if you sample just 2 shares, then the expected reward for the cheater is less than what he would get by just submitting the honest share, the valid share. Right.
How large are the batch shares, or how many shares are batched into one call? And isn't this against the philosophy of pools that just make smaller chunks of work?
Right. So here, by batching all the share, we do not increase the variance. What we do is we just delay the payment a little bit to reduce the cost for you. So the variance is still the same. Right.
So the probabilistic checks require randomness. Why do you take randomness?
Right. So we use right now we are using the Ethereum block hash for the randomness, and we show that even some attacker can drop the block to bias the randomness by just sampling 2 shares. We can still achieve what we prove, what we have shown to you. Like there's no advantage for the attacker to just drop the block. So this is surprising to us.